Okay, so we are going to do one more example, and this is the Newsvendor model with discrete demand. And so in this example, we are a company that sells swimsuits, and 6 months before summer, we need to determine the production quantity. And we produce one swimsuit. It would cost us $80. We can sell those per swimsuit at $125. And at the end of the summer, we have to discount them quite largely. And so we can sell them for $20 at the end of the season. And so if we look at past sales, knowledge of the industry, economic conditions, we create this probabilistic forecast. And so this is what they would call a discrete demand distribution. That means we only have discrete outcomes. We can either sell 8,000, 10,000, 12,000, 14,000, 16,000, or 18,000. You may say, okay, where does this happen? Well, what if your minimum order quantity is 2,000 from your customers? And so you would never, the probability that you would actually sell exactly 9,000 is 0 for this example. The other thing to remind yourself about in terms of discrete demand distributions, if I sum up the probabilities in this column, they will equal 1. And so the probability that the demand during the selling period is 18,000 or fewer is 1. So if I wanted to say I wanted to make sure every time, as long as demand followed this historical distribution, I would order 18,000 units. Okay, so what does that look like graphically? This is just that same table, only graphically. And then if you took the average, so remember the average is what's the outcome times the probability of that outcome. What's the outcome times the probability of that outcome? If you did that, you would get that the average is 13,120. And so that is right here. So the average is there, but there's a chance that it could be less or more than that each selling period. All right, so we have to ask ourselves how much to make. Again, the average demand is 13,120 swimsuits, but we need to look at the overage and underage costs. And so if an extra swimsuit is sold, we make a profit of $45. If it's not sold, so anything at the end, we lose $60 every time we sell a discounted swimsuit. And so we have to ask how much to make. And you can think about, do you think the optimal quantity will be less than, equal to, or greater than the average demand? All right, so let's calculate that. So the critical value is $45 divided by 45 plus 60, and we get a value of 0.428. Okay? And so our critical value of 0.428, how do we figure out what Q is? We need to use the cumulative distribution function. We need to find where the cumulative distribution is at least the critical value. So that happens at this point here, and that means we should order 12,000 swimsuits. So that's how many to make. And that's the optimal, meaning it will maximize our expected profits. And to note, that is actually less than our expected demand. So our expected demand is 1,300. We are going to order less than our expectation. That's because we have quite a high overage cost. So every time we have one extra unit over, it costs us $60 at the end of the season. Okay, so that's our typical news vendor. We can do this with any distribution, but we also want to think about expected profit. So I've been telling you, as long as you set Q star using the critical value, you will maximize expected profits. Let's now explore that. So what is your expected profit for your choice of Q star? So as a reminder, you have a discrete demand distribution. So that's our demand probability. We also know our demand, that's the outcome, and then we know the probability and the cumulative probability. And so we can figure out for each outcome, and there's 8,000 would be an outcome, 10,000 would be an outcome, and so forth. We have discrete outcomes. Given we order 12,000, we could figure out how much profit would it make. So let's just do it for this first row. So if we experienced 8,000, that happens 11% of the time. How much would we make? Well, we would sell 8,000 of them at full price at $125, but we'd sell the remaining 4,000 of them at $20, and we invested in 12,000 at $80. So this is our, like, you think about our selling values and then minus what we invested, and you would get that for this outcome, we would make $120,000. Okay? But that doesn't happen every time, right? That only happens 11% of the time. Okay, so that we just calculated conditioned on you have 8,000 demand, you would make $120,000, and that happens 11% of the time. All right, so my question to you, and this is a clicker question, is how much profit would we experience if demand was 10,000, and again, we ordered 12,000 swimsuits. So in other words, I want you to condition on that demand of 10,000 occurred. How much would you make? And so if you need some time, please pause the video and think through this. So the correct answer here is B. So the key here is to think about if demand was 10,000, that means we sell 10,000 at full price, we sell 2,000 at the discounted price, and we invested in 12,000 at the beginning of the selling cycle for $80, and therefore conditioned on that demand was 10,000, we'd make $330,000. And so that's this, but that only happens 11% of the time. All right, so my next clicker question for you is nothing has changed other than I want you to tell me what is the profit if the demand is 18,000 or 180,000 demand. So again, it's the last row here. And if you need to, pause the video and think through it. So the correct answer for this one is actually A. And so A is because the key thing here is even though we had demand for 18,000, we only had 12,000 swimsuits. So how many did we actually sell? We only sold 12,000. So the correct answer is A. We sell 12,000, we sell them all at full price. And that's the correct answer. We do not sell 18,000 because we don't have 18,000 swimsuits. So that's why A is the correct answer. So you could do this for each different outcome. And then if you remember the equation for expected value in a discrete distribution is what is the outcome value times the probability plus what's the outcome value times the probability all the way until you've gone through all of your outcomes. And so in our example, outcomes are demand in a discrete distribution. And so our demand of 8,000, we found out from the very first slide we did this, that we made $120,000 given demand was 8,000 and we ordered 12,000 swimsuits. If demand is 10,000, we make a profit of 330,000, and that happens again 11% of the time. One thing you note is once you hit 12,000, the same happens here. And that's because the profit that we make is limited at the inventory. And so we make 12,000, we sell only 12,000. And so this is the same value for profit. And so if I calculate this probability times my outcome plus my probability times my outcome, so the sum product of this column and this column, I would get that the expected profit is 470,700. And this is specific for Q star of 12,000, and that's the maximum we will get because we found 12,000 using the critical value. And so you can, if you say, okay, do I really believe you on that? Well, let's plot what are the other, what if I only bought 8,000? What if I bought 16,000? What if I bought 20,000? You can see that this profit, the expected profit, which is the y-axis, maximizes at 12,000, and it's the value we just found on the previous slide. So some key insights from the Newsvendor model is that the optimal order quantity is not necessarily equal to the average forecasted demand. Instead, the optimal quantity depends on this relationship between overage cost and underage cost. And as long as we set Q star using this critical ratio, we will maximize the expected profit of our situation.